Hello folks, welcome to the sessions of building serverless architecture using Azure Function. My name is Welly Lau. I work as Cloud Solution Architect in Microsoft APAC. Today we are going to talk about one of the very excited topic, which is serverless architecture. Let's look at the agenda. What are we going to discuss? I'll first of all start with the overview of the general serverless computing and see how does that differs to the typical cloud service model. We'll then look at the overview of Azure Functions and complementing it with one of the demo of creating the first Azure function. And then we start to do a bit more details and deeper look at the basic of Azure Function, including the programming model. We'll go over some of the feature highlight, and then showing the second demo, making use of trigger and binding to see how we can use Azure Function with some of the other Azure services. We'll then look at the various scenario how you can use Azure Function for, and then deeper to one of the case study, FUJIFILM software, how they make use of Azure Functions to power their core business. And lastly, we will conclude the session with the third demo, which I think one of the pretty cool demo. It's basically load testing the Azure Functions, and we will monitor it with the App Insight live stream. And without further ado, let's move on. Now, I believe you have seen this slide a number of times, a very typical cloud service model. On the first column, you'll notice that pretty much end-to-end is handled by the customer itself, right? That's a typical on-premise model. Now, the second, third, and fourth pillar essentially are the options of the cloud service model, right? Half of the stake will be handled by the provider, like Microsoft, in this case, in the infrastructure as service, whereas you still have to handle some of the other stack. On the third pillar or third column, you notice that they are getting less and less of the stack that you have to handle. Essentially, you just have to handle the application and the data. And lastly, on the right hand side, you notice that pretty much end to end are handled by provider. Now the question is, we understand all of this, but where do you think the serverless computing fits in? Now, before answering where the serverless computing fits in, I'm going to double click on the platform as service and zoom it into more details. If you look at one of the example of platform as service, app service is one of the most popular one. Now, within the app service or the platform as service in this context, you notice that servers are handled and managed by the provider. That is perfectly correct. But then one thing that I want to bring it up is, though it is managed by the provider, there are things that we still have to involve or define. And primarily there are two main things. First of all, it's you have to define something called the app service plan, or essentially it's a cluster size or the hosting plan, right? And we have to define, first of all, is the instance size, essentially the virtual machine size, which comprises of the CPU and the RAM. And essentially, we can decide how many of instance count we want that plans to be, right? So it's a size as well as the count. Now, definitely you can perform an auto scale by defining some of the metrics like CPU utilizations reaching 70% and increase the number of instances by 1 or 2. You can auto scale up and down in the app service. The second point that I want to make is, because in the Paas or app service, you reserve the capacity in terms of instance size as well as instance count, we essentially provide that pool for you, and you will, because you reserve it, that is what you have to pay for, right? And in this example, you will have to reserve and pay for 3 instances of P1 V2 VM size, for example, regardless or not are you using it or are not using it. when your app is defined or deployed the app service plan, that's what you will have to pay for essentially, because you are reserving that capacity, and we are not going to use the capacity that you reserve for somebody else workload, right? Now, if we look at the serverless computing, which is the evolution of Paas, so-called, it still inherits the characteristic of platform as service, except on the server side, you now no longer have to define the cluster size or the app service plan. And that is what Azure will do it for you, including the scale. Will scale it for you. And you will be, your service and the workload will be deployed in something called a consumption plan, or in this picture, you can look at something called a dynamic plan there. And that is the serverless, right? Essentially, your app will be running into a pool that Azure manage. And because of that, we will help you scale up and down, and you do not have an option to scale up or scale out by yourself, all right? And the good thing for that you pay for only what you use. If there's no workload, you basically do not pay anything, except a very small fractions of some of the other supporting service like bandwidth or storage. So that's where I think serverless as a model of evolutions of platform as service. Now, let's recap a bit of what we talked earlier by explaining the concept of serverless in the other cloud service model. The term serverless itself, it's actually a bit confusing or misleading, right? It obviously doesn't mean that there's no server. Obviously, there are server. It's just that we abstract away the server so that developer do not have to worry or be distracted about the service management, right? It's an abstraction. And the second characteristic is instant, right? And also it's event driven. That means you essentially do not have to worry about the server provisioning time, because we will do it for you. As well as the scaling time, right? When your workload grows, we will help you scale it. And then lastly is you pay for your use. No, as I mentioned earlier, if there's no execution at all, you'll get charged almost nothing. So the question is then, what are the benefits of serverless computing? I think first of all, the main benefits is because a lot of things will be abstracted away. You have a lot more times to solve your business problem rather than heavy lifting some of the plumbing infrastructure related tasks. And because you are now have a lot more time to focus on your business, we expect you will be able to develop your software a lot shorter so that it goes to the market faster, and then less wasted as well, because you will avoid the fact that under provisions or over provisions. And the other benefits is flexibility, so that you literally can start very, very small or almost nothing. And then as and when your workload grows, that grows accordingly. Now, in Azure, we have a number of serverless offering, and I think Azure Functions essentially stood in the center of the entire diagram, whereas it's a service that gels some of the other supporting service together, and then you make use of the execute your code base event to access your Azure function. Now we do have the other serverless offering like Logic App, and that is for workflow orchestrator. We also have something called Event Grid, that is essentially a service that manage a whole bunch of events and then triggers your code accordingly. The good things of the all-app Azure ecosystem is you can use the combinations of a few of them to make up the entire solution. You don't have to basically like choose one of all of them, so you can pick which one that makes more sense for you. Now, we also have a set of development tools that enable you to develop these solutions a lot quicker, including some of the IDE like Visual Studio and Visual Studio Code. DevOps also plays a very important role in serverless offering, and we have Azure DevOps as well as GitHub that enable you to build a CI/CD pipeline a lot more efficient. Let's look at more details on Azure Functions, right? Now, other than the typical functions service model, Azure Function also provides some of the integrated programming model, which we're going to learn a bit more detail shortly, something called binding and contracts. We also allow you to develop your code based on your preferred editor. You can use VS Code, you can use Visual Studio. These two provides a lot more rich programming features, but you can also use whatever editor you want, and we provide some of the CLI tooling as well. Now, Azure Function can be deployed into a number of hosting model in your local machines, on Azure, in fact anywhere else, because we open source the runtime. The typical flows of how Azure Function always start from an event, right? And that events could be react to a timer. So you can set a timer that execute every 30 seconds, and then that is essentially an event. Or HTTP trigger, when somebody hit that HTTP endpoint, you will want to execute your code in Azure Functions, or any more. Then you define your code in Azure Function, and you can write your code in a number of different programming language like C#, App Sharp, Node.js, Java, and so many more. And you essentially will have something called output, right? After executing your code, you may want to send an email notification, you may want to send SMS, you may want to save some data into database like Cosmos DB, or you can even invoke some other process else. All right, let's firstly show you the first demo of Azure Function. I'm going to switch over to my browser, and this is my Azure portal. I'm going to start by click create resource, and you notice that you can create something called a function app here. The function app is it's a container of an Azure Functions. Right? It's a logical grouping of Azure Function. And the typical first thing that you need to do is select the resource group, or you can create a new one resource group. I'm going to choose one of the existing resource group which I've created called RG Function Virtual Summit. And secondly, I'm going to name this Azure function called Virtual Summit version 2, let's say. Hopefully nobody uses this name, because you need to define some name that globally unique. And then you need to decide how do you want to publish your function code. We allow you to bring your code over or code it on the Azure Functions, or in case of you have containerized your app, we can also load it from a Docker container, and then you just have to define a container image, and Azure Function will help you run accordingly. So we have these two options. And for this demo, I'm going to choose the code options. And because I choose the code options, I need to define what is the programming language do I want to specify in my Azure Function. I'm going to choose Node, .NET Core in this example, and choose the data center region. So I think we support like 40 over data center regions worldwide, and I'm going to choose Southeast Asia. The next option is a hosting model. And as you can see that Azure Functions can run either on Linux or Windows, and because of my previous selection, I choose .NET Core, which is actually you can change to Linux now if you want to, but I'm going to leave it to Windows as per planned. And this is one of the very important option here. It's about the plan, right? Now earlier on, I explained to you the fact that we can have consumption plan where the plans change dynamically and scale accordingly. You actually can also deploy your function app into your app service plan, and when you do that, there isn't any additional cost to your function app, because you are basically piggybacking on the app service plan which you have provisioned. We recently also support something called a premium plan. That's basically target for enterprise that allow you to have to eliminate the problem of cold start and so on. For this demo, I'm just going to choose the consumption and move on to the monitor. So the Azure function is nicely integrated to the app insight. You can automatically create the app insight for you over here. I'm just going to move on, click text, skip this one, and click all the way up to review first plus create. And this will essentially take about 30 seconds or so. My Azure function will be up and running shortly. Now, while waiting this to be go up and running, what I'm going to click is the existing resource group, and you notice that under this resource group, I already have a few Azure function app. Look at this one called a virtual submit app. So earlier on, I have created this one. You notice that this Azure function app is deployed in Southeast Asia, and it has such a URL called virtualsummit@azurewebsite.net, and that's where you can start creating your function. Okay, and how would you like to do that? Is click create new directly under the your function app, and over here you notice that there are some quick start option for you to either create your functions based on HTTP trigger, a timer trigger, or some of the other options. You can also click on the scenario and choose one of the other scenario that makes more sense for you. And for this example, I'm just going to simply click a HTTP trigger. Oh, you notice that that was a previous one that we created together, and now it's successful. Or maybe let's just go to that one to give us a fresh new experience. I'm gonna click plus new. Over here, you see that there's an option for you to either choose the development environment if you were to use Visual Studio or VS Code locally, or you can also choose in portal. But I strongly recommend you to start developing it with Visual Studio or VS Code in the case where you would like to do a proper development experience, right? In portal is good for showing a demo, and that's where I'm going to start in portal over here. I'm going to click continue, and you notice that I've got an example of webhook API or timer. I will just start with something called webhook API and click create. So within a few seconds, you will notice that the Azure function got created, and there are some sample code that is up and running here, ready for you to execute. You can bring it up some of the console or log windows over here in the Azure portal. You can also look at some of the file that has been created for you. Let me zoom my browser in a bit so you get a better view. Right, so you have your function.json, you have your run.cs, and that is where your code is being executed. Now, this is where you start modifying your code and let it run accordingly. Now, what I can also test the functionality of this Azure function is either click on this test tab over here. If you look at the code is actually accepting either a request body or a query string. So if I lift this to Azure and I just simply hit the button of run, you will notice that it will say hello Azure and responding 200 OK. Alternately, another option is you can just get this function URL, and I'm going to copy this one, open a new browser window, and I'm going to put, if I just going to hit something, you notice that it expect you to pass a name in the query string, so the request body. So if I say name equals to a Wally, you notice that it says hello Wally because this function simply expecting a query string with the name. Okay, so that's pretty much all summarized the first getting started Azure functions. Let's move on to the slide. Now, one thing which I'm going to show you a demo a little bit later, it's the concept of triggers and binding. So we mentioned that you can define the trigger based on HTTP, based on timer based on the queue message, and so many more. Now, it depends on the programming language that you are using. Every language have defined the program model slightly differently. In this example, if you were to use C#, you will start to add attributes over here, say queue trigger, and that basically tells that if there's a new message coming into the queue, this method run will get executed, right? And then you can also define something called output binding. Basically, the output binding defines where, in case of once you have processed all the necessary code in your business logic section, it could output to another place else. In this example, it's another queue called my queue item destination, right? And if you look at function.js, that basically define a bit of metadata of how these functions being defined, including the details of where you got your queue, what is your queue name, and the SDK sample. So that's a basic programming model, which again, I'm going to show you in a bit more details later on. Just bear with me. Now, let's look at some of the other key features of Azure Functions. As I mentioned to you, triggers and binding, these are the two programming constructs that enable you to write your function code a lot more efficient, because you basically do not have to import your SDK and library manually and call the typical client library. This allows you to develop much more quicker. Well, you can if you want to, making use of the standard SDK, but with the binding and trigger, essentially accelerate your development. The other capability is when you use VS Code or even Visual Studio, that enable you to have your local debugging, such that if you encounter some other issue that you need to debug, likewise, you still can use your IDE to debug locally before publishing it to the real Azure functions. Some of the other capability like CI/CD also applicable here. You can use CI/CD making use of Azure DevOps or GitHub or whatever CI/CD toolings that you prefer. Application Insight, I show you the demo already that you can use App Insight for monitor. Again, I will have the last demo of using App Insight live stream. I mentioned earlier that Azure Functions support a multiple programming language, C#, JavaScript, and so many more. Hosting options. Durable function, it's an extension of Azure Functions. Though Azure Functions typically allow you to execute a small specific of function and then you're supposed to get it done a lot quicker. Azure Function is an extension that enable you to run a long-running functions that perform something like orchestration job, right? So you can have this option, and we'll see some of the case study later on that use durable functions in productions. So earlier I mentioned that there are a few options to host Azure Functions, and the first demo that I showed you was the consumption model, the true serverless model. But you can also deploy your function into the standard app service plan, the typical app service plan that we all familiar with. Likewise in the app service environment as well. And other than that, you can also deploy your functions into other out of public Azure environment by Azure Stack. Run your Azure function in your local server, or else like a IoT edge as well. Another things that make Azure Functions very unique is fully open source. Almost everything's open source, starting from the function host is open source. You can look at a link over there. The web job SDK, the durable functions, including the templates, the samples, all are publicly open source in GitHub. And over the times, while this is developed by Microsoft, we have received a lot of contribution from the open source community, and then their contribution has significantly influenced the product of Azure Functions. So feel free to contribute to the Azure Function based on the link that I provide here. All right, let's look at the second demo. Now the second demo, how it works is I will have two Azure functions, right? The first function, based on trigger, what it does, it will execute every, let's say, 50 minutes, 60 minutes, or whatsoever, and it will fetch the data from an external weather provider, and that function called record weather. So how it works is I constantly ping the weather service provider and try to parse the data and eventually save it into a Cosmos DB. And then I can have a second function, and that second function will act as an API layer to serve my web UI to pull the data from the database. So it's pretty simple and straightforward example, not rocket science. So I'm going to show you the example in Visual Studio. Okay, so first of all, I'm going to show you the first function called record weather. Now, as you can see, I define my Azure function based on timer trigger over here. Look at that. And here I have my cron expression, basically define how frequent I want to run my Azure function, right? So that is my trigger. It's on timer. The other thing that I want to show you is the output binding. And this example here is I am going to output the binding into a Cosmos DB with the database name weather forecast, collection name weather forecast container, and the details of the connection string name. The connection string name is the Cosmos DB connections, and obviously I can store my details of the value in my local setting.json. Okay, so my code is basically trying to get the details from the external service or web service that returns me a set of JSON file, and I'm going to do my parsing accordingly in order to get the weather as well as descriptions, right? The weather was in Kelvin, and therefore I have to convert to Celsius first, and then I will just have to say the temperature in Celsius is this value, the summary is this descriptions, and then the date time is the current date time, right? Additional codes that I provide here, I think it's just simply get weather in JSONs, and I'm making use of HTTP client to access the other web service. So very simple, very straightforward, nothing fancy. This thing runs every, I think I said it runs every 60 minutes or so. Now, if this will output essentially into the Cosmos DB. So in this example here, allow me to show you the Cosmos DB, and hopefully all file has been successfully saved into Cosmos DB. I'm going to click on this Cosmos DB, this NoSQL database that uses Cosmos DB. I'm going to choose Data Explorer. Now, Data Explorer will allow you to browse all the data that you have in Cosmos DB, and in a very short while, you'll be able to see the Explorer happening here. Now it's connecting. Okay, there you go. I am now going to open the items. So look at that. So these are the items that got pulled from the external web service provider, and then my Azure functions will execute and then store the data over here. So you notice that the first function is essentially store all the file in this database. Now I'm going to show you the second function. The second function is this thing called weather forecast. It provide an API for my web UI. Okay, what it does is very straightforward. This will have an input trigger of HTTP. So unlike the previous one was timer, this one is HTTP. That means that when you hit an HTTP endpoint, it will get executed. The second thing that I want to show you is this will also have a weather forecast Cosmos DB as a data binding. That's why we call it input binding. And then what it does is, what I'm going to do over here is just basically pull the data from Cosmos DB as my input binding, and then look through the result before throwing the result out as HTTP. Okay. Now, if I were to execute my let me go back over here. Weather forecast. Let's go Virtual Summit. I think it's this one. All right, over here. So this one called a weather forecast. Now, if I were to execute this URL into the browser, you will soon see this is the data that I'm getting. All right, there you go. So this is the data that I'm getting. Basically pull the top 10 from Cosmos DB. Now I also have the web UI. My web UI is running on .NET Core Singular, nothing fancy. It's just a web user interface, which I put it onto the app service. So allow me to open my app service. Weather, I think it's this one, weather web.azurewebsite.net. There you go. Look at that. So this essentially is a web UI that fetch data from the second API that runs on Azure Function. Okay. All right. I made this code available on GitHub, so feel free to go check it out and learn a bit more. I'll provide you the link at the end. Moving on to this slide, there are tons of scenario that you can use Azure Function for, right? Making use as a web application backend, which what I showed you earlier. You can use it for a mobile backend, IoT, and so on. I'm going to just show you a few more that is more frequently used. The first example is a web application backend. Now this one is a little bit variant to the previous one that I provide. What you can do is create web applications, and what it does is whenever somebody do an order, and you can put the message into a service bus queue, and then you can have your Azure Function listen to the service bus queue, and then execute the Azure Function, store the necessary information into the Cosmos DB. So that's one example scenario. I'm using Azure Function as your web application backend. The other variant is mobile application. What it does is you may have your Azure Function that provide API as your backend, and then your web application will access that API, and then that will essentially store the data to the Cosmos DB. Optionally, you may have the second Azure Function API that listen off the Cosmos DB and then do the necessary push notification all the way back to your mobile application again if you need to. The other scenario, you can make use Azure Function for real-time processing. Say somebody drop a PDF files into a specific blob storage, and then you can pick up that blob storage and then decompose the PDF files, call an Azure Cognitive Service to perform the OCR detections, and then detect the digital format of the files and store it into a structured data like a SQL database. That's also a common scenario. Real-time stream process, it may be a IoT-like scenario where tons of devices producing a lot of telemetry data in a very high scale, and then you can use some of the elements like event hubs to perform the data ingestions, and then that will let Azure Function to process it accordingly, and then store the data into the Cosmos DB and eventually display into dashboard like Power BI and so on. Another example, now this is more like a independent standalone example. let's say a SaaS application, you can use Azure Function to extend a SaaS app. Let's say you may have a GitHub issue and you create a webhook call to listen whenever there's a GitHub issue, and then the webhook can be actually runs on Azure Functions, and then you provide the URL that you created with Azure Function into that webhook URL setting, and then within your code of your Azure Function, you can raise something issue details in Slack or so. So that's also one scenario. So I'm going to show you the other case study, and this is a real case study. One of our customers use Azure Functions already in productions and has been pretty successful. FUJIFILM software, it's a software arm in Japan that produce one of the solutions called ImageWork. What it does is these solutions it essentially enable photographers in sporting events to perform a tagging, and then eventually this software will output a series of recommended image that they can use it for productions. So initially they were using a lot of manual human process work, and you can look at some of the screenshot here of this software called ImageWork, right? This is used in NPB, Nippon Professional Baseball. The challenge, a lot of challenge that they faced was manually tagging it will require a lot of time. And then what it does is they making use of Azure Function with cognitive service to detect some of the baseball player, let's say. Those who can have face clearly visible, they definitely can use the machine like cognitive service to detect who are the persons. But you can use combinations of this with a manual process as well. So this is the technical architecture of how these solutions are being developed. The photo got imported basically by a lot of photographer which runs around during the sporting events. And then essentially that will got pushed into the queues on the cloud. And then they make use of Azure Search that can further do some analysis. And then they might want to do some image processing, making use of the Azure Function, and particularly in making use of Azure Function as an all-up image unit. And then they can call Face API, which subsequently invoking the Cognitive Service API as to do the face recognitions. And then there's another function called extrapolation image that output a set of analysis result into the database. And with that, ImageWork and FUJIFILM software will be able to significantly reduce the times compared to the traditional manual process. All right, I'm going to move on to the last demo. Now this demo is very excited, but this demo is trying to load test the flexibility and the elasticity of Azure Function. Let's see how it does. Is I will have a Apache JMeter will hammering an Azure Function URL, and then as soon as I generate the load, you'll notice that the number of server load grows, and in order to monitor it, I'll use the App Insight monitoring tools that monitor it. So let's move on to the last demo. So I already have a URL called WALI-F. So that was this one / I think it's HTTP. All right, it's this one. It's very simple. It's a hello. Very simple to the earlier that we created, except this will have a bit of delay because I want to essentially pass the load and let more threads to be run. And then I have the application inside example here. This is the App Insight live stream metrics. Right now you notice that a while ago when I hit this URL, there was a request, and that was me actually. So this is almost in real time, and you notice that just now there's only one server online. So we're going to perform a load test which I prepared the agent over here. This is running on a VM on Azure with a JMeter. What I'm going to do is spin up 1,000 thread and look for 5 times and do a hammer to my Azure function URL called welef.azurewebsite.net. And as soon as I hit enter, I'm going to move back to my live stream metric. Notice that it started creating a load now. And I want you to monitor this live metric here. Start to increase the number of server online. You notice that? And if I scroll all the way down to here, you will notice that here are the number of server got provisioned in order to handle my load. Okay. This number over the time will increase more and more. Now you notice that there will become a 5-6 server. If I scroll a bit down here, you will notice that each of the server will start taking a new request, right? So Azure Function will help you monitor your scale, and then whenever they think we need additional host power, it will then provision some other machine else. Now we've got 9 server online, 10 server online. Let me go back to my load testing. Yeah, I think this is still progressing. That 1,000 thread is still hammering my Azure function. All right. I'm just going to leave this to run in the next couple of 30 seconds or so. When I did this experiment, I think went up into about 36 server or so, and you notice that was the elasticity that Azure function will help you to provide. Now when the load is over, you will notice that this number won't goes down immediately to 0 or 1, but it will gradually go down if there's no traffic, and because that will have a cooldown period of time. Okay. Yep. Look at this live. This is the load test. Is the thread start going down? That indicates that the number of load tests start simmer down. You notice that also over here, I now have no more or very minimum requests. That pretty much complete our load test. It went up to 16 server, serving 1,000 requests for a 5 load. Okay, so now you start seeing that without have to configure my auto scale at all, it will help me perform the auto scale. And with that, one thing that you might want to check it out, it's there was an interview to the Azure CTO Mark Rosinovich, and then over this article he talks about he strongly believes that the future of cloud is serverless computing, and then what are the roles of Azure and Microsoft playing serverless computing. So feel free to check this out. I think this is a very good article. And to learn more, you can go to the first documentations of the Azure Function doc. It basically has everything that you need to get started with Azure Function, starting from the Getting Started guide, some of the video, the documentations. Now you can also check out the book, which I actually co-author with my good friend Agus. This book is about the practical aspect, right? You can start doing the hands-on with this book. It will guide you through a few scenarios, which I showed you earlier. Again, the sample code is also available into the GitHub link over here, and you can look at some of the other case study in this last link. And with that, I want to thank you so much for your times joining these sessions, and I hope this presentation is useful. Thank you very much.